Good morning to all of you. Very sorry because of all these problems. I'm not with this software, so it was confusing, a bit confusing to me. So I hope everything is fine now, and let us begin. Yeah, you have the title of my presentation. I'm going to talk about alarmist scenarios versus objective data on sea level changes. I think that is very important because all the media are full with people saying that the coastal cities are going to be flooded and millions of people will be obliged to run away from their homes. So I think this thing, sea level changes, is a little complicated because when you see the curves, you are seeing something that is relative sea level change, and so you are not in a stable environment. You are on Earth, and Earth can go up and down, and that's the fundamental things I'm going to tell you, so you can decode the alarmist information we get on the media all the time. So I'm going to do this also as a tribute to two people that passed away recently. The first one was Professor Morner, which I knew quite well from more than 30 years. And here you can see him climbing a 90-meter cliff on an island in the center of Portugal. And it was just 1 year before he died. So it was a very energetic person, as you know, and he really loved field work. This Müller was a wonderful person with very clear presentations, and I owe them both a lot. We must follow their inheritance, that's what I think. And for this, you must get real information, and you must always and also think by yourself. Because this sometimes is not so easy, but is important, because if you follow up all the ideas that are traveling around the world about this subject, will be very confused, and you will be maybe afraid of things that are not going to happen really. I'm dealing with this subject for more than 30 years, but here is one of my first presentations on this. And I would like also to show you how to make some research on this subject. You can go to this Permanent Service for Mean Sea Level site, and then you will see a kind of map like this. So you have all the tide gauges in the world, and you can see that sometimes they are in white, sometimes they are in black. White, they have data after 2019, and black, they have data before 2001. So you can see that in Portugal, the data are not very actualized, which is a shame. Going also to another place, to know a site, you can see the spreadsheet where they put the trends they calculated with the Permanent Service for mean sea level curves and trends. And you can see also a map, and you can do another interesting thing, which is to see it in Google Earth. This is the arrow showing how to do it. Okay, I hope now you see the presentation moving. Do you? I can't understand why. So the title, my homages to Professor Nicholas Morner and to Thomas Wissmuller, and my ideas about their inheritance. So you must get real information and think by yourself. I'm doing some work on these issues for a long time. The best way to do it is for yourself to go on permanent service for mean sea level site, and you will get the information about all the tide gauges in the world. They are represented in white when the data are actualized, and in black where it is the data are before 2001. So I also got the NOAA site because it has some differences. It's more easy to map, to make some cartography, and so I used it quite a lot. You have here the link for seeing it. They present this kind of map where you can see in the legend, you can see that are places where the relative sea level is going up, and the arrows are to up, and places where, imagine, sea level is going down and the arrows are down. And here you have the trends represented by different colors. Another view of the same thing. And what I did was to uh, edit the CapML file in order to simplify the names and to put a bigger font so you can see not only the names but also the trends of each tide gauge. And what you can see is that here in Scandinavia you have places where this is going down near 8 millimeters per year, and then this figure is going down also. So in the indigo you have 5 millimeters, and in blue, light blue, you have between 3 millimeters and 1 millimeter of sea level going down. Then you have places where the sea level is going down also, but in a very light way. So about less than 1 millimeter per year, or even is a stable sea level, as relative sea level trends show. The sea levels that you can see on the tide gauges. Then around it, all this area, you will see places where the sea level is going up, not very much. It depends on the places. And in some places in the southern Europe, you can see that sea level is going up a little more. So they are represented in yellow here and here, and even in orange. Professor Morner did a presentation, which the link is here, and you can see the idea. The center of Scandinavia was subsiding in the last glaciation, and then is coming up because of is free from the load of the ice, and so this area is coming up, and the adjacent area is going down. So is the so-called forebulge, where the sea level rise because of the downing of the earth is bigger than usual and than normal, so to say. Here you see the data about the movements, because only land movements can explain that. And so you have coming the land, and here in blue you have subsiding of the land. And in that area, of course, you have this transitional area I told you about. And of course, these movements of the land, they create very different, but really very different sea level curves. Yeah, you see this sea level curve, the sea level is going obviously down. It corresponds to relative sea level of high values, 8 millimeters, 4 millimeters about, and then you have places where the sea level in this area, the sea level is more or less stable, and you have these curves, this curve in Bergen, and then around it you have in the Four Bulge area where the continent is going down, and you can see it by all these arrows, mostly the blue ones, of course. And of course, because of that, what you have is a coming up of sea level, as you see here and here. Going to the south, to my land, Iberia, the sea level changes, the trends of sea level changes are represented here with the same legend. And so you see that most of the places you have a rising sea level, but with values that are from, you'll see, not very great. So at Sines you have bigger than 3 millimeters, at Cadiz also, at Port-Ventre in France also higher than 3 millimeters. But at Alicante you can see level is going down also. So something must be in place, something must be happening for this to happen. With the permanent service for minimum sea level, you can get a link to a text file, and to transform the text file like this in a curve. Sometimes the data are not good, so they are eliminated. And of course, with only this part, this good part of the curve at Leixões. Leixões is the harbor near Porto, my city, and doing the trend, I see a millimeter year rising of sea level. At Santander in northern Spain, you have about 1 millimeter. And what I can say also is that Leixões, you have here at 2015 the highest sea level record on this trend, and at Coruña is before, is about 1997. At Vigo, the same thing. So not in the present, can you see? 2020, and not in the present, so there is no acceleration. At Cascais, which is the tide gauge near Lisbon, the trend is about 1 millimeter, 4 per year, and is a bit the bigger, the higher moment is a bit later, but not 2020. And Lago, which is in the southern of Portugal, in the Algarve, you can see also that this highest point is before 1990, so not very recent. At Cadiz, in the southern Spain, near the mouth of the Guadalquivir, you have a higher number, and I will talk about this in some moments. But again, the highest point is not recent, is before 2000. Ceuta, the sea level change is already in Africa, as you know, is a possession of Spain, but in Africa. And so the sea level rise is very low, and also before 2000. At Malaga, in the Mediterranean coast area of Spain, you have a bigger trend, but also, can you see, about 2007. Now, going to the islands, at Azores Islands, you have a higher sea level trend, but again, the maximum is in about 2010 or so. So, making a summary of all this, you can see this, and then in a kind of summary, you have green areas where the sea level rise is between 0 and 3 millimeters, and yellow more than 3, and even places where the sea level is going down. So I think when you compare these two Greek islands, Greek area, you can see the more or less the same thing. So you have places where sea level is going up less than 2 or 3 millimeters. Then you have some places, quite rare, where the sea level is more, rise is more than 3 millimeters, and even a place where it is more than 6 millimeters. But of course, you know that Greece is a tectonically active area. So in this place, of course, the tectonics are going to interfere on relative sea level changes. And around the world, in the same file of the NOAA, you can see places where you have at Manila, for instance, 14 millimeters, and in this place, 16 millimeters, but they are all in active tectonic places. So this is really something that you must got out this presentation. To understand how the land is moving, you can go to SONEL, this Système d'Observation du Niveau des Eaux Littorales, and you have a lot of information here. You have sea level trends and land movements. And in sea level trends, you have the relative to the land and the absolute. And I'm going to talk a little about this absolute geocentric sea level changes. Here you have a general view of the world, and you can see that sea level in relation to the center of the Earth, geocentric, the real eustatic changes, not discounting on the land movements, they are quite rare, above 2 or even at least 4 millimeters per year. Most of the time, you have a very low sea level, absolute sea level rise. These places can be studied, of course, to understand why the numbers are so big, and I'll try to give you some ideas about this case. But another thing you can see on this SONEL site is the GPS data for some of these tide gauges. For instance, Cascais, the most important tide gauge in Portugal and the longest on the Iberia. You can see the tide gauge here and the GPS is here. So they are nearby. The GPS gives one idea of a going down of the land. You see this trend, and so they calculate this. So it's stable, but with a trend to go down the land. So if you have 1,4 sea level rise, you must subtract this data from the land movement, and so you will have about 1 millimeter per year. At Lagos, you have also a sea level curve. This is the relative sea level trend, and here here you can see that the land is going down too. So the real absolutely sea level is less than 1 millimeter. At Ponta Delgada, this is a different, in the Azores, is a different kind of problem. You have a higher sea level rise, but when you see it, you have also down. The GPS is showing that the land is going down. And another thing, the GPS is quite far away, more than 1.5 kilometers from the tide gauge. So it's possible that in this area you have different tectonic situation than in this other area. And you will see that generally near the coastline, the trend is for going down. That's the truth. So the geocentric sea level should be about 2 millimeters. At Cadiz, another thing I would like to tell you, because it's painted in orange in the maps, you have a great sea level trend, more than 3 millimeters and a half. But the tide gauge is here in the city, near the harbor of Cadiz, and the GPS, which is used to balance, to correct the tide gauge, okay, is about 11 kilometers from this tide gauge. So this should not be used simply. Of course, the GPS gives a great horizontal line, so it seems that in this area the land is stable, but maybe in this area is not stable, and this can explain why the sea level rise is more than 3 millimeters. Here I have the accounts I made for Portugal. They are not available on these maps. And here the other numbers of absolute sea level. So we must distinguish very well between relative sea level and absolute sea level. And of course, here you have Cadiz, who is the biggest here. And some areas around Iberian Peninsula, a little to the north, you have average of 1.5 millimeters per year. Of course, all these can be explained by the movement on the continent outside the ex-glaciated areas. In the glaciated areas, you have the land coming up quite a lot, as you can see, more than 6 millimeters. And around it, in these four bulges, you have places where the land is going down. Most of them are places where the continent is going down, and sometimes you have also places where the continent is coming up. So in this area, in the southern Europe, of course, because of alpine tectonics, you have recent movements, recent earth movements, you have earthquakes, and you have the so-called neotectonics that makes the land coming up sometimes quite fast. And so it interferes with sea level change. So here I have the proof. We have the proof that the movement of the land are really important to understand us. Looking around all the Earth, you can see that places where the absolute sea level, and I must say, make a parenthesis to say that absolute sea level is what must bother us, because if land is going down, we can do nothing about it. But what we must be afraid of is if really the sea level is going up, because it can make erosion, it can destroy our coastal towns. This is true. So you have 4 or 5 places where the absolute sea level is more than 2 millimeters, and more than 4 millimeters, sorry, and most of them are in these mild areas. With the data from the NOAA site, we can export all these spreadsheet, and you have the distance from the GPS to the towed gauge and the absolute sea level trend. And with this, I did this graph. What I have, the latitude, north and south, and you can see all the tide gauges and the GPS are concentrated in the northern hemisphere and in higher, more or less higher latitude places. And what you can see is that absolute sea level rise is comprised between minus 2 millimeters and 4 millimeters. The other places here they are shown are outliers, and the outliers, of course, can be seen in a moment. But the average of these is about 2 millimeters per year of absolute sea level rise. Here you can see the outliers that can be studied. It is very irregular, all these situations, and they are the places where the absolutely sea level trend is more than 4 millimeters per year. Of course, you can use also the satellite altimetry, and satellite altimetry can give us should give us some trend, global trend about all the Earth. And the numbers are 3 millimeters, which is more than the average, as you see. And they think they show us an acceleration on the sea level rise based on satellite altimetry. But as you have seen in the curves, that's why I was showing you a lot of curves, we couldn't see no acceleration on sea level curves. So why can we believe on this so-called acceleration on sea level? I don't believe in that. A map shows that the satellite trends for sea level change, they are quite clear in the open ocean. So, and they configure more or less, they make a design of the marine currents. You have, for instance, Gulf Stream. And so the sea level is rising here, not continuously, but sometimes in some places rising, sometimes it's falling. But in the coastline, you see first not very much of a rising sea level, and they specifically say that these satellite imagery cannot be used to predict relative sea level changes along the coast. So I think that the people that is using the satellite altimetry for studying sea level changes is committing an error, a real error, because this is not designed for changing sea levels in coastlines. For changing sea levels in coastline, you have permanent surface for mean sea level and zonal site. This thing is more about marine currents. As conclusions, the values of sea level rise, discounting the movement of the continent, are on average 2 millimeters a year. But there is a discrepancy between these and satellite altimetry that are bigger. But all these satellite altimetry shows a lot of corrections. Sometimes we have some doubts about the algorithms they used to do this kind of thing, and I'm sure, because the average is 2 millimeter, and I'm being quite sympathetic about this data, maybe is less than 2 millimeters. So if from this average you pass to 3,4 millimeters, there is something of an exaggeration. And also, what I said before, they can be used to assess what really matters, sea level variations on the coast. But when you go to the media, and I'm going to use the data of Wikipedia because it's a place where everyone goes, and so they say that in 2100, in the end of this century, we could have a rising sea level of 26 centimeters or 98 centimeters. When you make the accounts, it means that sea level rise should be about 3 millimeters in this case and 12 millimeters in that case. And you have seen that if 3 millimeters can be compatible with the satellite altimetry, this is completely foolish. But no one, don't forget that 26 centimeters is not a big thing. No one is afraid of a 26 centimeters, which is possible. No one is afraid of a 26 centimeters rise in sea level. And so I remember our Professor Morner curve from sea level in the end of Little Ice Age. We have a lowering of sea level about 12 centimeters lower than 1970, which was the year where he made his thesis. So you have this curve. It means that sea level must be rising because we are living a moment of low temperatures where the Thames were frozen, and you can have frosty fairs, and the recent times where happily the Thames is not frozen and you have higher temperature. So making the accounts, of course, from this point to this, it should give about 0.86, so less than 9,9 millimeters, less than 1 millimeter per year, and is not a bad number at all. Because the last conference that Professor Morner showed us in 2019, some months before the COVID pandemics, it was one of the last slides he showed. So he believed that sea level could rise, as you see, 5 centimeters to 15 centimeters. This account could give about 16 centimeters in the end of this century. So nothing of the catastrophic views we are used to listen. Here you can see the some sites, some links. If you want, I can send you the PowerPoint presentation so you have access to all these sites, and they will allow you to reconstruct all the things I have done and to see by yourself and to criticize a bit better with knowledge, with a real based knowledge, the catastrophic ideas that are circulating on the media. And thank you very much for your attention. Very sorry for all the problems we have, okay? So I'm available for you to make questions. I don't know if
thank
the
you.
time
Yeah.
is okay.
Thank you, Maria, for your presentation. And wir haben jetzt Zeit für ein paar Fragen. Professor Lüdecke.
Darf ich in Deutsch fragen? Ja, Sie übersetzen. Also erstmal recht herzlichen Dank für den sehr interessanten Vortrag, der viele Veröffentlichungen bestätigt, viele Fachveröffentlichungen bestätigt. Ich habe eine Frage, die mich auch immer umgetrieben hat.
Ja.
Woran liegt es, dass die Satellitenmessungen höher liegen? Also es ist ja so, man muss ja auch bei den Landmessungen immer Korrekturen machen und Rechnungen machen. Also das Rechenverfahren spielt eine Rolle. Wissen Sie als Expertin hier Näheres, woran es liegt, dass die Satelliten offenbar falsche, zu hohe Werte liefern? Das ist die erste Frage. Die zweite Frage, ganz kurz zum Schluss hatten Sie Ihre eigene Veröffentlichung gezeigt. Es wäre schön, wenn man die mal gesehen hätte, in welchem Fachjournal das erschienen ist, Ihre Arbeit. Danke.
Okay. So about this curve, I'm not very much aware of the way they do this kind of corrections, I must say. The last place where I was, it was in Munich in 1918. I think that Professor Wissmuller and Professor Morner agreed that might be some algorithm that is not going good. Because this is not possible, that if the average of sea level change, absolute sea level change is 2 millimeters, you can have more than 3 millimeters. So there is an adjustment, and Professor Morner was very angry about this, an adjustment of data, so it gives the result we want. And of course, we can find another thing, the explanation, the real explanation of this, but we can feel that another problem is that these altimetry curves and maps satellite altimetry curves and maps cannot use and this is specifically said in this place, cannot be used to predict relative sea level changes along the coasts. And what they do is to predict relative sea level changes along the coast. So I think this is my finding. The most important finding is that they contradict themselves. They said sea level is going up more than 3 millimeters, but then they forget that this is in the open sea and not in the coastline. And what we must care about is the coastline. About my articles, of course, this one I show you was the first one about these places, about this subject, but in this area, in this link, you can see all my other presentations. Some of them are in Portuguese, of course, most of them are in Portuguese, but there are some in English too. And of course, I can help you if you send me some email to give you the information, all the information you want about this subject. I must say that it is from 1916 to the present that I'm dedicating my time to understand the changes in sea level. It was much for the influence of Professor Morner, I must say, because my best contribution to science, I think, is the geomorphology, geotectonics, sea level changes on my coastline, because they are influenced by the tectonics and of course by sea level changes. You have my thesis, which is old, It was from 1991, but you have more recent works, and some of them are available even in some presentations on YouTube on these conferences. It's the third time I appear here, and also in London conference. These can be seen here in these these links.
Maria, we are a bit short. Maria, thanks. We were a bit short of time. So actually
okay, thank you. Thank you so much.
Okay, so in this regard, I don't know, we have two people who would love to question. Is it essential that we? Okay, we have 2 minutes left, so we have two questions, but we try one. Okay, be short in the answer, please.
No, I have. You don't have to answer. I just have for a long time had a rule of thumb. Geological speed is measured in centimeters per year. This sea level change is measured in millimeters per year. So that usually, as soon as land moves, it's at least three times as fast.
No, not at all. It's not, the numbers are not centimeters per year, are millimeters per year. The scale is the same. Okay, of course, land can be going up or down, but in a trend which is comparable to the sea level changes, not bigger.
Okay, excellent.
Okay.
The last one, Maria, the last question here.
Yeah?
Maria, could you just explain very shortly how the tide changes, daily tide changes, are taken into account when we measure the sea levels with the tide gauges?
Okay.
Especially.
I'll try. I'm not an expert on this, but for instance, here you have Cascais, for instance, which is the main tide gauge in Portugal. You have a tide gauge where the sea level is seen from the low tide and high tide, and you have averages every month. These are peaks. These peaks represent the average of 1 month in 1980 something. Okay, so this is mostly data for sea level changes. They are very accurate and very well, I hope, well done. And this is treated by permanent service for mean sea level. It's not something that you can send and they will believe you. No, this is done with the harbor's authorities, and then it must be accepted by permanent service for mean sea level. And of course, I have not here a photograph immediately. I could find one, but you can, if you Google tide gauges, you will see the look of that a tide gauge and is registration can have. Now, tide gauges are mostly electronic, and they have better results, of course. But of course, they must be carried on, because sometimes the tide gauge is suffering from the movements of the land, as you see, and sometimes they are destructive. Sometimes things are changing because it is a very active, a very dynamic environment, the seaside.
Maria? Maria, thanks a lot, really, for contributing to our conference. It was great. Thank you.
Thank you very much, and sorry for my problem.
Yes, and we all hope that next time it will be again in real person.
Surely,
that we meet.
surely.
Okay, all the best.
I will know
See you soon.
Software better. Thank you very much, Wolfgang.
Okay, bye. Okay, jetzt gehen wir mal gleich weiter. Ohne